Yeah. Okay. The first time I presented this session, someone told me that this is not really Fast and Furious. This should be something like that. That is more like it. So that is pretty much all my slide art. I'm not professional in making slides like Martin or Christian was amazing. Okay, a little bit about me. I'm Reza, staying away from the speaker. Power BI MVP and Microsoft Fabric MVP for some years now. Regional director, which means that I'm not working for Microsoft. I'm not regional. I'm not director. It's just a title. Anyway, I have written some books that you can find some of these in Radacat website. I write blog in Radacat website. How many of you are familiar with Radacat, by the way? Oh, okay, nice. Welcome back. If you want to connect with me, go to Radacat website. We have a YouTube channel as well. I hear some echo. You guys hear that as well? A little bit? No? Okay. Anyway. Okay. That's pretty much it. How many of you are familiar with Microsoft Fabric? That's good. Power BI? Everyone. Okay, right. Just a very short introduction to Fabric because we don't have much time. What is Microsoft Fabric? If you have used Power BI is a data visualization tool. Microsoft Fabric combines that data visualization tool with few other tools in Microsoft, one of them being Synapse, the other one being Azure Data Factory, to provide a full end-to-end data analytical solution. Using this, you can do anything you need in a data analytics project, from connecting to the data sources, transforming the data, doing the data engineering, data warehousing, data science project if you want to do on top of it, real-time projects, Power BI for doing the visualization, and all of that uses a same storage, let's say, layer. We call it OneLake, which is behind the scene Azure Data Lake storage. It is AI enabled, meaning that you have Copilot in different parts of it as well. Anything without Copilot these days doesn't really matter, right? And you can combine it with Purview to get some governance around it. This whole thing together comes as one product called Microsoft Fabric, except the Purview is like a separate thing. You have to purchase it separately to get it. So that is Microsoft Fabric, right? Like that example that Christian showed you in the previous session, something like that. If you want to build that end-to-end, Microsoft Fabric is one of the tools you can use to build that, right? Anyway, that was all of my slides, demo. Right, okay, what I'm going to do is, most of you are familiar with Power BI, so what I'm going to do is a little demo. I'm going to get data from an Excel source. Let's assume this Excel in somewhere in OneDrive for business or something like that. I'll bring that into a storage place. We call it Lakehouse. Consider Lakehouse as a database or a data warehouse. Then what I'm going to show you is what the Power BI connection to the objects in that Lakehouse is, which we call it Power BI Direct Lake, which is the main subject of this session, right? So I'll start with going into data engineering experience here, creating a Lakehouse. Let's name this Melbourne. What is this user group name? Data Platform User Group. Okay. Okay, debug, right, okay. So I'll create a Lakehouse. Lakehouse is like a database. Consider it like a database created in the cloud. It is supported using a Spark engine, parallel processing engine that supports like large volume of data. It can process it at really fast speed. Now I want to get data into this. I'll start with creating a data flow. Those of you, like most of you, familiar with Power BI, when we do data transformation in Power BI, what component is used for data transformation? Power Query, great. You can use Power Query online, which is called data flow. This is that, right? I'm using Power Query online. I'm getting data from a source. In this case, let's say this is an Excel source. Where is copy link? Here it is. So I'm using this as an Excel source. Similar to the way that Power Query in Power BI Desktop works, this would scan your tables, list of tables. It would list that for you, and then you can go and choose which tables you want to do and get data from. So I'll go and choose a few of these tables. Let's say customer table, product table. I'm not going to do a whole lot of transformation. I'll just add some of these tables. Sales table and create. So these are basically just 3 tables I'm adding within this place. Here I can do some extra transformations on top of it if I want to. Let me just wait for a little bit so that this show me a preview of data. Again, you worked with Power BI. This is like the Power Query editor inside Power BI Desktop. This is the online version of it, which also gives you like this nice graphical interface as well, where you can do some transformations right in here. Like, for example, let's say in the customer table, I'm only interested in customer key column, first name, last name, and middle name. What else? Gender, if we have education, something like that. Education. Let's say all of these, and right-click, remove other columns. Things like that that you normally do in Power BI Desktop. And this would create extra steps. Like here, you see that for the customer table, I have all of these steps. I can go back to the previous steps, see what the data looks like, all of that. But one of the things that we have in this is called Data Flow Gen 2. If you have worked with Power BI data flows before, that is what we call Data Flow Gen 1. Data Flow Gen 1 and Data Flow Gen 2 has one big differences, and that is the data destination that we have inside Data Flow Gen 2. This means that I can have this transformation result loaded into a Lakehouse, Warehouse, Azure SQL database, or KQL database, any of these 4 options, right? So let's say I'll choose Lakehouse, and that is the Lakehouse automatically selected because I've created that Lakehouse first and then created that Dataflow Gen 2 from there. Okay, let's call this Dataflow something, not Dataflow 1, Dataflow debug again, not depop. Okay. Publish. So when I publish this, what happens is that this would basically save all of my transformation, all of that structure in a JSON file behind the scene. That publish process basically creates that. After the publish is done, this would refresh that data and load it into the destination that I mentioned. In this case, this will be that Lakehouse, right? So waiting for this to come up. Usually when I'm waiting, it's a good time to ask any questions. I know we haven't talked much about anything yet, but if there is any question. Okay. Yes? What is driving that? Is it Spark or something? Very good question. Behind the scene, it's a Spark. Yeah. But the Spark is not the behind the scene of the data flow. It's behind the scene of the Lakehouse and Warehouse, that experience, especially when we work with the notebook with that experience. That is the Spark engine we are interacting with. Dataflow is a custom Power Query engine hosted in the cloud. So it still works sometimes in a parallel processing scenario, but it's never something close to a Spark. So if we have large volume of the data, Dataflow might not be the best transformation tool. We might go and do a Python script, work with that Spark directly. Okay, that is refreshing. Let me just see if there is any data in here. So those tables, when loaded, yep, here it is. You see these tables, I can click on these tables and I'll see the data of these coming gradually. This is a trial license I'm using, and we have shared it in the course with some other people, some other users. So this is a little bit slower than normal. Anyway, this is that data. This is that customer table exactly as I built it. So far, nothing special about Power BI Data Lake. So far, we have created a Lakehouse. We fed data into that Lakehouse using Dataflow Gen 2. Thanks.
Fabric. It's a Fabric workspace. You have to set up as a Fabric workspace, or it's now automatically convert to a Fabric workspace.
It has to be a Fabric workspace. So that workspace, you have to go to the setting and
I think everyone knows that.
Yeah, in the license. If you have a Fabric trial, this automatically in the next workspace you create, it automatically becomes that one. But to make sure, it's always good to go and choose that capacity, because I don't have the capacity paid one. I'm using the trial. Yep.
And you can convert an existing Power BI workspace
into that. Yeah.
You have to do that
before you can. Yes, otherwise it wouldn't give you that option. But one thing to be careful, especially if you use the trial one, is that if you convert your Power BI workspace to a Fabric workspace, your trial ends, you just have 7 days to do something about it. Otherwise, it will remove everything, even your Power BI objects. And that is not good, right? Okay, let's continue on this. So this is my Lakehouse with the data tables. Now, what I'm going to talk about here is this structure of the table. This is the important bit. This little triangle sign you see beside these tables, this is the sign of Delta Lake table. Now, what is that? I have a few more slides. Now, I'm skipping a lot of these, as you see, because this is supposed to be a much longer presentation. I'm just doing the shorter part of it. So that triangle sign is actually this sign. This is the sign of Delta Lake. Delta Lake is an open standard format for storing tables. This is the format that Spark engine, the engine that we just talked about, behind the scene, understand this format. What this format actually looks like. So this format is a way that we store the data of the tables. It supports quite a lot of things within that format. It makes your Spark engine act like a normal database. So you have your normal transactional database operation using that. You have something called time travel, which is a really interesting feature in Delta Lake table. This means that if you want to go back and have a look at your data 2 days ago, this time, you can do that, even though the data gets updated, right? This ability is something called time travel, which comes with the Delta Lake. I'll talk about it. And some other features. Anyway, let's skip that. This is the structure of a Delta Lake table. So usually you have a folder. Let's say if I have a customer table, there's a folder for that customer table. Under that, I would have a bunch of Parquet files. These Parquet files have the data, which I'll talk about it in a second. Then we have a log folder. Inside the log folder, we have a bunch of JSON files. JSON files are information about what is changed in each of these Parquet files. To give you a little bit more context, let's talk about Parquet itself. What is Parquet? Parquet is a format of storing data in a file. It's basically a file type, like CSV. Probably everyone here is familiar with CSV. CSV is the format of storing data. CSV is human readable. If you open CSV in your computer, you can read it. It's a row-based data. Parquet is not like that. Parquet is storing the data, but in column store format. This means that if you have redundant values in your data, this would reduce them. It would create like a little index table. A lot of details behind the scene, but what happens is that it would reduce the size of your file significantly when it stores it. So it stores it much more efficiently. Depending on the amount of redundant values you might have within your CSV file, sometimes you change your CSV format to Parquet, it would become like 10 times smaller, same data, right? So it's much more efficient when you write data into that. It is also much more efficient when you query data from it. And that is one of the reasons why Spark engine behind the scene uses this, and the Delta Lake uses that. So back to this structure, those Parquet files basically are your data files. Every time data changes, you might have more Parquet files created, right? And then the JSON files are saying things like what file has changed at what time. And that is how they provide this time travel ability. Let me show you these files in the actual environment. So here, this is my Lakehouse. If I go and click on one of these and go to view files, it shows me that these are Parquet files. You see, let me zoom in a little bit. So these are two Parquet files. You cannot see the Parquet file itself. You can install something like a Parquet file reader, but you don't really need to. The Spark engine should understand it. I click on the Delta log table, and here I have the Delta log folder. Here I have the JSON files. What the JSON file looks like, that is interesting. This is an example of a JSON file structure, which is interesting. Sometimes it comes formatted, sometimes it doesn't. Anyway, this is what it looks like. The part that I'm interested to show you is this. So there's a timestamp saying that at what time a modification happened. And then it tells me that at that time, what Parquet file is probably either created or removed or something like that, right? So as you make changes in your data, like the next data flow refresh, the next data pipeline refresh, the next update on the data, as those changes happens, new file get created. New JSON files also get created pointing to those new files saying that this is for yesterday, 8 a.m., this is for today, 3 p.m., things like that, right? And that is what provides you the ability to do the time travel. So when you say, I want to look at this data last night, it knows where to point at. This only keeps the data up to 30 days. More than 30 days, it doesn't. Anyway, this is not a session about time travel, so let's skip that. This is a session about direct lake. Now, what is direct lake? Let's talk about that bit a little bit. I'll again skip into some of these, get to here. Okay. Pretty much everyone here works with Power BI. In Power BI, we have a few different types of connections. You can import data, you can do direct query, you can do live connection, composite model, and this new one, which I'm going to talk about here, direct lake. To understand direct lake, let's talk about import and direct query very shortly first. What is import data? When in Power BI, when I connect to a source, one of the default types of connections usually is import. This means that it would create a copy of data from that source, brings it into Power BI, and it saves it into Power BI's own proprietary file format. You don't see that file, but there are files underneath in the program files folder. There are places that those files are stored. The way that those are stored are columnar storage because that is the most efficient storage available. It makes it fast to write. It makes it fast to read. That is why this type of connection, import data, is one of the fastest types of connections in Power BI. That is why we always recommend people to go and use import data whenever they can, right? There are two problems with this, however. One problem is what about the size? Because you are importing the data, your file size gets bigger and bigger. Depending on the Power BI license that you use, like Power BI Pro, for example, PPU, or premium different levels, you get different allowance for the size of the model. That is one limitation. The other limitation is that because this copies the data, every time you want fresh data, you have to get this data set, the semantic model, refreshed, right? These are the two limitations on that. Then on the other hand side, we have direct query. What direct query is saying? Direct query is saying that, well, we would not copy data from the source. Let's keep it there. I would have a connection to that data source. I'll pull the structure of the table names, column names, relationships, data types of columns, all of that, but not the actual data. The data is still living there. In my Power BI report, every time I look at a visual, every time I click on a filter slicer, it generates a SQL script. It sends that SQL script to the data source, get the result, send it all the way back to Power BI. It shows me that result. In one Power BI report, you don't have one visual. Like how many of you have a Power BI report with one visual, right? We don't have that. Usually we have like 4, 5, 6 different visuals. This means 4, 5, 6 different queries sent to the data source, or a combination of those, which still is more than one a lot of times. That makes it really slow. That is one of the reasons that direct query is like super slow. This is one of the types of connections that we usually don't recommend unless you have to, right? But the good thing about this is that it is always live. You don't have to refresh the data. The size of data doesn't really matter. It can be petabytes of data in the data source, and we would be fine with it. So those are the existing types. But what is this direct lake? So the direct lake is the interesting one, because if you think about that import data one more time, import data, what it does, when you connect to a data source, it gets data from it, it saves it in a columnar store format, in its own proprietary file format, and uses that for analysis. Now think about Parquet file. What Parquet file does? Parquet, or Delta Lake Table, is pretty much doing the same thing. It saves the data in columnar store format, right? So then in a situation like this, that Power BI connects to the data in a Lakehouse that is stored in a Parquet format, what is the point of creating a copy of that, storing it again columnar store, because it is already columnar store over there, right? So what the Microsoft team did, which was quite a smart move, I think, was that they changed a little bit in the engine of Power BI, so that when it connects to one of these objects like Lakehouse or Warehouse, that they store their data in one lake as a Parquet format or Delta Lake format, it considers those Parquet files as its own proprietary file. So from Power BI point of view, those are actually Power BI files. It doesn't need to import it. The files are already there, right? The performance is like import. It's not exactly like that. There are like some differences, but minor differences. But it acts like an import. On the other hand side, because these are the actual data files of those tables, as soon as the data gets updated, your Power BI semantic model have the new data. You don't need to refresh that. This is called direct lake. So direct lake basically is a performance similar to import with the freshness of data similar to direct lake without copying the data. You still have one copy of that data in that lakehouse table or warehouse table, wherever it is. So one of the most efficient way of connection you can have. Let me show you how this works. Back to the demo. How much time we have? Is that the question or how much time?
No, I have a question.
Okay, we'll get to the question in a second. I think we have like 10 minutes or like that, right? Okay, let me do the demo. Whenever it is taking time, I'll get to your question. Okay, so what I'm going to do is in this lakehouse, I'll switch to what we call as a SQL analytics endpoint. This is where we see our model like a normal database. Here it is. What I'm going to do is I'll go and create a semantic model on top of it. Let's call this debug semantic model. Select all of these tables. This is a custom semantic model. You could use the default semantic model coming with this, but the custom semantic model usually have much better editor. It's a better option to use in a real world scenario. Okay, now this is taking time. So question.
Yeah, I think like with the direct query, normally there is a limitation in terms of what text you can use compared to the import model. What about with this mode?
There are some limitations in direct lake. We'll talk about that. Let's get to that. But definitely there are limitations in direct lake, not necessarily related to the DAX measure you are using. This might be limitations in terms of the number of rows you are fetching, things such as using SQL views instead of tables as a source, things like that. Those are limitations. But we'll talk about it. So this is my model. I can go ahead and create relationships in here if I want to. Let's just create one just to show you that this is possibility. So this is the sales table, product key, connection to the product key. I'm not really going to use any of these relationships in my example, so let's just leave it. Let's say this is my model, right? I'll create a new report on top of this. Which is connected to the same semantic model. And I'm going to do a very simple report, just showing the total sales amount in here as a card visual, $29 million. What I'm going to do in this report, I'll turn on the automatic page refresh. So let's get it refreshed every 1 second. This is the page refresh. This is not the semantic model refresh. So, right? So as soon as the new data is available in my semantic model behind the scene, this would see that because this is set on an automatic refresh. Let's save this. Report auto refresh. Refresh was not correct, but anyway. Okay, you should see this little thing here that does the refresh, right? But this is just a visual refresh. Now let's go back to my workspace where I have this lakehouse. I want to do an update on the lakehouse so that you can see the impact of that, like how long does it take to come over there. On the lakehouse, the update commands cannot run on that SQL Analytics endpoint. So what I'll go and do a new notebook here. Notebook is a data engineer tool. Usually we use that to do any form of like coding, data engineer, data science experiment. I'll connect to my lakehouse over here. Was it this one? Yeah. Thank you. And I'll change this to be a Spark SQL code. In Notebook, you can write your code in 4 different languages. I'm going to just write a simple update command. Update fact internet sales, set sales amount to some number, right? So this makes every single transaction in that table like that. So that number should become more, right? Let's run this. It takes a little bit of time to run. Let's check the report. It is still 29. Oh, here. Oh. This is still running. Usually it takes more time to create the connection than running itself. Once the connection is established, then it should not really take much time to run. This is also another good time for questions. This is slightly different than what we had in Synapse as a serverless or dedicated pool or things like that. They changed it. Right, you see, this is, sorry, I interrupted in the middle. So you see, it was pretty fast. As soon as I came to the report, the value has changed. It's not always this fast. Sometimes it takes a few seconds. But that is how the direct lake performs. I don't really need to refresh my semantic model. Now, back to your question, it's not exactly any of those. If I want to say it is similar to one of those, probably it is more close to serverless. But they have done quite massive changes in the way that the engine works. Like you can consider Synapse engine as engine version 1. This is like engine version 2 behind the scene. Quite different. Back to this. So we talked about the fact that this updates automatically, right? But there is actually a little update happening behind the scene. Let me show you that. When I go to that semantic model, this one, to the setting of that, here it is. Under refresh, you see that there is actually a refresh. Although we said that you don't really need to do data refresh. So what this is not actually a refresh. This is, there's a different term for it. This is called reframe. Reframing, in this case, means that back to that Delta Lake structure, remember, how was it? Like a bunch of Parquet file, a bunch of JSON file pointing to which Parquet file related to which time. When Power BI connects to that, Power BI connects to one of those latest Parquet file at that point of the time. But the data gets updated. Power BI needs to get notified that what is the latest Parquet file for that point of the time. That is that reframing process. So this refresh is basically that reframing. It doesn't necessarily mean that it is refreshing the data or anything like that. You can turn this off if you want to, which can be a good situation, good thing to do if you have a long ETL process. Within your ETL process, some of the tables loaded, some of them not loaded. So the values in your report might be like incorrect if they get updated immediately. You might, in that case, turn it off and then do the semantic model refresh through your pipeline process at the end of data flow loading, anything like that. Yes. New Parquet file, you mean? Yeah. Usually changes would come with new Parquet file. So yes. It creates a new Parquet file. So the whole thing would be one Delta table. It would create usually new Parquet file. It's not necessarily every time you make a change, it would create a new Parquet file. Sometimes it runs on batches. And that is why sometimes it runs on a few minutes delay, things like that. But that is the process usually, correct?
Reza?
Yes.
If you're on Power BI desktop, and I'm probably talking exactly the chair, going desktop, connecting to direct lake, you obviously can't, like that's part of the problem. I realize
one of the limitations.
One of the limitations to kind of integrate your data and your star schema
using the desktop.
You've got to go back and get the star schema.
Correct. But that is as of now. Based on what I've heard, that feature is coming very soon. So very soon we would be able to use Power BI Desktop to manage this model. At the moment, only in the website. We can't do in desktop. Yes.
Not sure if it's a similar question. If those existing Delta tables can we leverage the same?
Where do you have those existing Delta tables?
Let's say it's in ADLS Gen 2 storage.
Okay. Like where did you create them first? In Databricks or something like that? I don't think so, because it has to be V-ordered enabled. You can use them to get data loaded into that using V-order enabled. Am I right, Darren?
You can shortcut make your list into S3, GCP, AWS.
Amazon S3, all of those, yeah.
The only caveat with Delta table coding outside of Fabric is the order compression. Fabric applies, which you might see less performance. So you want to test performance sufficient with those Parquet files, or should I try ingestion processes?
Thank you, Darren. Thank you. And by the way, that V-order, in case you don't know about it, V-order is an optimization technique that Microsoft actually added on top of this Delta table that makes the performance better. It also makes the file size slightly smaller, so more efficient usually. That is Microsoft only. Like if you go and build a Databricks Delta Lake table, they don't have V-order. They have something else like Z-order, Z-order. I get always this like Z order. They have Z order. We also have Z order here. That is like an industry standard. Everywhere Spark and Delta table is used, that use that. But V order, the one that Darren was talking about, this is only within here.
It doesn't break compatibility with the Delta table. So you could run an optimize the notebook like Fabric, and it'll write back to ALS and
Thank you. Just a very quick couple of slides and then wrap up. This direct lake has some limitations. One of them was what Lance mentioned. You cannot build this solution at the moment using Power BI Desktop, but that is going to get solved very quickly. There are few situations that would cause fallback to direct query. One of those situations is that when you purchase Fabric capacity, there are different sizes for the capacity. Those capacity sizes, they come with like these guardrails. Like for example, if you pull too many rows from your semantic model, it would cause some limitations on your capacity. As a result, it would fall back to direct query. And as a result, the performance would go significantly down, which you would have some options. You can say, well, I don't want fallback to direct query happen. Like you can do some settings. If you do that, you have to be careful that this might cause an error in that case. So you have to make sure that you have enough capacity to cover for that kind of situation. I'm not going much into that details now, but there are some settings you can control around that. So that is the fallback or some of the limitations that might happen in here. Or if you use, for example, a SQL view, at the moment SQL views are not supported in that directly situation. If you want to go and create like a calculated column or calculated table, at the moment those are not supported either. But in those cases, I would suggest go and add those as the columns and tables in your warehouse and lakehouse. That would be the right way to do it anyway. Okay, I think that pretty much about time. Any more questions? Yeah, pretty much like that. Yeah. If you watch this.
I'm struggling to keep up, so they're like, tomorrow night you go a bit slower.
Yeah, tomorrow I'll probably talk a little bit slower and talk more.
So tomorrow will be directly direct query rather than directly speed.
Yeah, tomorrow speed would be direct query. Yes. Cool.
I have one question.
Yes.
Directly, are there limitations around, say, pulling in data from different columns of different tables and grouping them? So grouping by one column against another set of columns.
In your visualization, you mean?
Yeah, well, you basically, so you want to group against a particular column and aggregate the data or something like that. I'm just sort of, I haven't dealt with direct link before. I'm just wondering if there are limitations in that, or.
Okay, so the question is that with the direct lake, is there any limitations when we do things such as grouping data by a particular column, things like that? That would depend on where do you do that grouping, things like that. If I'm doing all of those, for example, in my data transformation process, that is probably happening in data flow before loading it in my Lakehouse or warehouse. So when the data comes, it is in the Delta Lake format. So everything is direct lake anyway. If the grouping is what we do in the visualization side, like create a visual that the slice and dice sales amount by this, that would also still work. In terms of DAX measures or things like that, is there any limitation? I don't think there's any limitation in the DAX measures. Am I right, Darren?
I was gonna, technically, because they've got that fallback to SQL,
Yeah.
they need to run in direct query mode. So there are limitations.
If it gets to that situation. But before that, DAX calculation should be pretty much like an import. Yeah. Yeah. Okay. You're welcome.
Keeping transformation minimal, isn't it? Because the Lakehouse is just the raw.
It's like our data warehouse database structure. You can use it as like a raw transformation source, like a staging area. And then from Lakehouse, you use some transformation, build it more like a star schema dimensional model into the warehouse. Like build your medallion architecture. This is my bronze layer, and then my warehouse is like my silver layer. On top of it, I have Power BI semantic model with direct lake connection. That is my gold layer, things like that. That is usually a type of solution we would go and build.
One last one.
Lance, yes.
Data marts.
Yes.
It was the big rage when it came out.
Yeah, I was one of those people responsible for that.
Is it still like that, or kind of like feels like it's kind of waning a bit?
My feeling is that because right now you get pretty much everything you have with the data mart with the data warehouse. You get the same experience, all of that. You get even data flow gen 2. You even get the direct lake. Whereas with data mart, we have direct query connection, Azure SQL database, like is a slightly older version with the data flow gen 1. So my feeling, and I don't have inside information, my feeling is that it's either gets updated to one of these new technology, or it basically just gradually disappear. Because it has been like 4 years in preview right now, right? So if you are building a solution now, warehouse or Lakehouse, those would be definitely better option. But if you have a data mart at the moment, be careful. Yeah. Yeah. Maybe Darren, some inside information or no?
I loved your answer.
Okay. Thank you. Why, in terms of why, I don't really know. But I would say that is correct. Yes. Yeah. Very good point. Yeah. So why cannot do calculate? Because it requires a full refresh of the semantic model. And better choice usually is to do your calculated column back in the Power Query, or using T-SQL, build a column within your actual data warehouse, because then you would use it in other places, in other semantic models too. Anything else, Kelly, or we are good to go? Okay, thank you everyone for attending. I'll pass the stage to Martin. Okay.